Hello friends, I Dr. Sonendra Gupta, Professor, Engineering Mathematics and Department of Basic Science. In the previous lecture, we have discussed about the two lectures and the definite integral limit of sum part 1 and definite integral limit of sum part 2. Now today we are discuss about the summation of series part 1. Now first of all, we discuss about the definition of summation of series. As you know that if f of x be any bounded and continuous integral function in the closed interval ab, then the integral a to b f of x dx equal to limit h tend to 0 h f of a plus h f of a plus 2h up to f of a plus n minus 1 h, where h equal to b minus a, or we can say that nh equal to b minus of a. Now the above expression can be written in this form. The value of a can written in the a plus 0h, a plus h, that means a plus 1h, and so we can. Here we see that the value of 0 is changed and like in this way. It means that if the value of if the values are changed, so we can say this is the value of r. Now the required summation is limit x tend to 0 h summation r equal to 0 to r equal to n minus 1 y, because the value start from the 0 and end on n minus 1. That's why we can write there 0 to n minus 1 f of a plus rh. Now say this equation number 1. Now taking a equal to 0 and b equal to 1, so we can say that if a equal to 0 and b equal to 1 here, that means h equal to 1 upon of n. It means that h equal to 1 upon n, that means if h tends to 0, then n tends to infinity. Okay, therefore the integration is integration 0 to 1 f of x dx equal to a limit n tends to infinity 1 upon n summation r equal to 0 to r equal to n minus 1 f of r upon of n. Now this is your required formula for changing the in summation of series. What will we do here? Here we compare on both sides. We can say that the value of x is compared with the r upon of n. That means r upon n is replaced by the value of x. Okay. Then the dx is replaced by this dx is replaced by the 1 upon of n. Dx is replaced 1 upon n is replaced by the of dx, and the third summation and the limit is replaced by the integration. Summation, that means the limit n tends to infinity, and summation is replaced by the integration. Now what is the remaining here? Here the remainings are the limits, lower limit 0 to 1. Now this lower limit 0 to 1 is evaluated by the summations lower and upper limit values. How? So here we can see that comparing on both sides, like in this mesh, then the upper limit is limit n tends to infinity. We have r equal to n minus 1 in the upper portion of the summation series, summation values. That means putting the value r equal to n minus 1. So we can say that n tends to infinity n minus 1 upon of n, which is equal to 1 minus 1 upon of n. That means 1 minus 0, that means a 1. And the lower limit n tends to infinity, here that's in the summation we have r equal to 0 is a lower value, so we can put the 0 upon of n, which is the 0. This 0 is always, that means in the summation of series question the lower limit is always 0. Now we discuss the sum question, then you will better understand how to solve the summation of series problem. Number 1, prove that by the summation of series limit n tends to infinity 1 upon n plus 1, 1 upon n plus 2, 1 upon 2n equal to of log 2. Now we can prove how. So first this limit n tends to infinity n plus 1, n plus 2, 1 upon 2n. Now we say this is the value of I. Now we generalize this term here, n plus 1, n plus 2, then that means the value of the 2n can be write in the terms of the n plus of n in this way. Here we see that the value is 1, 2 and n are changed, so we can write in the terms of the summation, which is called the rth term, which is the r equal to 1 to n, which is the 1 upon of n plus r. What will we do? Next we will do the taking the common the value of n, which is the 1 upon of n. 1 upon n limit r equal to 1 to n, 1 upon 1 plus r upon of n. Here now say this equation number 1. By the summation of series r upon n equal tends to x, 1 upon n is replaced by the dx, and limit n tends to infinity, summation replaced by the integration. Next we will find the upper and lower limit. The upper value of the summation is r equal to n, and now we putting the r equal to n here, then we get n upon of n, which is equal to the value of the 1. In the lower limit r equal to 1, now 1 upon n, now putting the n tends to infinity, that means 1 upon infinity equal to 0. Therefore our integral is I equal to 0 to 1 dx upon 1 plus x. Now we integrate the 1 upon 1 plus x, which is equal to the log 1 plus x. Then we put the limit, that means 1 plus 1, that means the log 1 plus 1, which is equal to the log 2, and minus log 1 plus 0, that means the log 1 is 0. Then we get the value is a log 2, and this is your required answer. Now our second question is evaluation by summation of series limit n tends to infinity 1 upon n, n plus 1, 1 upon n plus 2, 1 upon 3n. So we can write first is the value is I equal to limit n tends to infinity of this much. Now here we see that the first term is n, the last term is 3n, and the rest of the term is the n plus 1, n plus 2. So we can say that the first term is n plus 0 and the last term is n plus 2n. So we can write in this way. Here we can see that 0, 1, 2 and 2n. Therefore the value of r is changed from 0 to 2n. Then in the terms of the summation, we can write n tends to infinity r equal to 0 to 2n 1 upon n plus r. Again we are taking the value of the n is common, which is equal to 1 upon n, r equal to 0 to r equal to n, 1 upon 1 plus r upon of n. Now say this equation number 1. Again by the summation of series we have r upon n is replaced by the x, 1 upon n replaced by the dx, and limit n tends to infinity summation replaced by the integration. Now again we find the lower and upper limit. Now upper limit is limit n tends to infinity r upon n, where the r equal to 2n in the summation form. Now we can put r equal to 2n in this way, that means the limit is 2. Okay, and the lower limit n tends to infinity r upon n equal to r equal to 0, that means 0 upon n equal to 0. Therefore the required integral from the equation number 1 we can get integral 0 to 2 dx upon of 1 plus x, which is equal to log 1 plus x from 0 to 2. Now putting the upper limit minus of lower limit, that is log 1 plus 2, then minus log 1 plus 0, which is log 3 minus equal to of log 3. Now this is your second question is solved. Now a third question is limit n tends to infinity n 1 upon n square, 1 upon n square plus 1, 1 upon n square plus 2 square plus 1 upon n square plus of n square. Now first it is written is I equal to of this much. Now here we see that the first term is n square and the rest of the term is n square plus 1, n square plus 2 square, n square plus n square. That means the first term we can write in the n square plus of 0 square. So we can say that 1 upon n square plus 0 square, n square plus 1 square, n square plus 2 square, n square plus n square. And we can say that the value is change is 0 to 1, then 1 to 2, then 1 to n. It means that summation is changed from 0 to n. Okay, so n, now this is your n summation r equal to 0 to n 1 upon n square plus r square. Now we can common the value is n square, that means n upon of n square, that means 1 upon of n. Okay, now say this equation number 1. Again by the summation of series we have 1 upon n is replaced by the dx and r upon n replaced by the x, and then the limit of summation replaced by the dx. Then the upper limits are limit n tends to infinity r upon n, r equal to n, that means n upon of n, which is n tends to infinity equal to 1, and the lower limit r upon n, r equal to 0, that means 0. In the each question we can say we have to see that always the lower limit is 0. Therefore the integral is 0 to 1 dx upon 1 plus x square. Now 1 upon 1 plus x square is integrate, that means we get tan inverse x. Now we can put the upper and lower limit, that means the tan inverse 1 minus tan inverse 0, which is equal to pi by 4 minus 0, that means a pi by 4. The required answer is pi by 4. Now the fourth question is find the limit when n tends to infinity of the series summation r equal to 1 to n, n square upon of n square plus r square to the power 3 by 2. Now first this is the value of the I, and the second, now we can take the common is by n square, that means the n square to the power 3 by 2, it means the n cube, that means n square upon of n cube. Now this n cube is cancelled by the n square, so we can say limit n tends to infinity 1 upon n, r equal to 1 to this 1 upon r upon n the whole square to the power 3 by 2. Now say this equation number 1 by the summation of series r upon n to replace to x, 1 upon n replace to dx, and limit n tends to infinity summation replaced by the integration. The upper limits now we get the 1 and the lower limit we get the 0. Therefore, the integral is integral 0 to 1 dx upon 1 plus square whole to the power 3 by 2. Now, this integral is not integrate directly, so we can put the value of x is equal to the tan theta. Tan theta, that means the dx equal to sec square theta. So, upper limit is theta equal to tan inverse 1, which is the pi by 4, and the lower limit theta equal to tan inverse 0, which is the 0. Therefore, I equal to 0 to pi by 4 sec square d theta upon 1 plus tan square to the power 3 by 2. Now this 1 plus tan square is equal to the sec square theta whole to the power 3 by 2, that means the sec cube. Now this sec square is cancelled by the sec, that means the 1 upon sec yani ki cos theta. Now cos theta is integrated with respect to theta, which is the sin theta 0 to pi by 4. That means sin pi by 4 minus sin 0, which is equal to sin pi by 4 equal to 1 by root 2 minus 0. Now this is the required answer is 1 by root 2. Now we have solved the four question. Here we solve the question number 4. Now here some practice problem for you. You can solve this question 1, 2, 3, 4 and 5. If you have any problem solving this question, you may ask in the lecture comment box. Thank you so much.